Okay, so I want to record these momentum review problems for you. The first one is pretty much straightforward momentum. It asks you for the momentum of the object. It tells you that the mass of the object is 4.32 times 10 to the 8th kilograms, and it tells you that it's moving at 11.6 meters per second. I believe this is the Titanic that it's talking about, so I know that momentum is P and it's equal to mass times velocity. My mass is 4.32 times 10 to the 8th kilograms, and my velocity is 11.6 meters per second. So the momentum of the slow-moving Titanic is 5.01 times 10 to the 9th kilogram meters per second. Okay, number 2 says that we have automobile manufacturers do crash tests, and so what we have is the mass of the car is 1,000 kilograms. The initial speed of the car is 14 meters per second. However, it's going to be brought to a stop, so the final speed is 0. And the time taken for that to happen is 8 times 10 to the minus 2 seconds. Or that's how long the seatbelt acts on your body. So for part A, it says, what force do you experience? So the impulse, F delta T, is equal to M delta V is what I'm supposed to do. So the impulse lasts for 8 times 10 to the minus 2 seconds. The mass is 1,000 kilograms. And the change in velocity is negative 14 because it's final minus initial. So the retarding force, or the force that slows you down, is a negative 175,000 newtons. All right. And I think you're also supposed to give them the momentum of the car, and I didn't solve for that, so let's do that. P is equal to mv, so I have 1,000 kilograms times a negative 14 meters per second, and actually I'm just going to use that as a positive 14 because they want to know the momentum. So that's 14,000 for the momentum. Okay, number 3. Number 3 says that you have a mass of 80 kilograms. Shelley has a mass of 80 kilograms. And she applies the brakes to her car. She's initially going at 30 meters per second, but then she goes to 0. So VI is 30 meters per second. VF is 0 meters per second. And we have 2 conditions. We have a condition where she's going to have the seat belt exert a force on her, and then have the windshield exert a force on her. So if the seat belt stops her, the time is 0.4 seconds. So they want to know what is the force when the seat belt stops her. So F delta T equals M delta V. So I have F delta T. Delta T is my 0.4 seconds. Her mass was 80 kilograms. And her change in velocity would be final minus initial, which is a negative 30 meters per second. So the force that she experiences in that situation is a negative 6,000 newtons. And it's negative because it's a retarding force. And then I want to go through the same thing, but this time I want her head to be stopped by the windshield. Well, that's not what I want, but that's what's going to happen. So F, the change in time for that one is 10 times 10 to the minus 3 seconds. Her M is still 80 kilograms. And her delta V is negative 30. So in that case, the force that she experiences is much different. It's a negative 240,000 newtons. So you can see the damage to her head is going to be much more substantial when she does not wear her seatbelt. Okay. Let's move on to number 4. Hang on a second. Okay, it looks like we might be having some issues here with our electronic device.